Do you know what are the characteristics of the oxide of period 3 elements? In this video, we are going to look at acid-base character of the oxide of period 3 elements.
Now we look at oxides of period 3 elements. How to form an oxide? An oxide is usually formed when an element reacts with oxygen. For example, sodium oxide is formed when sodium metal reacts with oxygen. When magnesium reacts with oxygen, the oxide form is MgO. For aluminium, when reacts with oxygen, the oxide form is Al2O3. And for silicon, when reacts with oxygen, the oxide form is SiO2. And for phosphorus, when react with oxygen, the oxide form is P4 or Tang. And for sulfur, when reacts with oxygen, the oxide form is SO3. And for chlorine, when reacts with oxygen, the oxide form is Cl2O7. Many will be wondering, how do we get the formula of an oxide? So basically, the formula of the oxide is derived from the oxidation state of an element. Like for example, sodium, it is a group 1 element, so its oxidation state is +1. We know that for oxide, the oxidation state will always be -2. By knowing the oxidation state of the element, then we can deduce the oxide by cross the oxidation state. We ignore the charge to give us the oxide for sodium oxide as Na2O. Same thing goes for magnesium oxide. So magnesium group 2, so the oxidation state is +2. Again, oxide oxidation state is -2. When we cross, we get 2,2. So we can simplify it to give us the chemical formula for magnesium oxide as MgO. For aluminium oxide, so aluminium is in group 13, so the oxidation number is +3. And the oxide is again -2. When we cross the oxidation state, again ignore the charge, then we get the oxide for aluminium oxide as Al2O3. And for silicon, it is group 14 element, so the oxidation state is +4, and the oxygen again is -2, so ignore the charge, and when we cross, we get 2,4, so simplify, we get 1,2, so we get the oxide for silicon as SiO2. And for phosphorus, it is group 15, so the oxidation state, so for phosphorus, it has more than one oxidation state. So here, I'm using the highest oxidation state, so it's +5, and for oxygen, -2, so 5,2, cross, we get 2,5, and the oxide of the phosphorus should be P2O5. And this P2O5 compound is not stable. So basically, 2 P2O5 will combine. So 2 P2O5 molecule will combine to give us more stable oxide for phosphorus, which is P4 or 10. And for sulfur, it is group 16 element. Again, it has more than one oxidation state. And the highest oxidation state is +6, so I'm using the highest oxidation state here, and the oxygen is -2, so 6,2, we ignore the charge, cross, we get 2,6, so simplify 1,3, so we get the oxide for sulfur as SO3. And for oxide of chlorine, so chlorine group 17 element, again it has more than one oxidation state, but here I'm using the highest oxidation state fluorine, which is +7. Again, oxide -2, so ignore the charge, cross, we get 2,7. Therefore, the oxide for chlorine has the formula Cl2O7. Now we move on to look at the nature of the oxide and solubility of the oxide in water. For sodium oxide and magnesium oxide, they are basic oxide. Sodium oxide is soluble in water, while magnesium oxide is only partially soluble in water. Since sodium oxide and magnesium oxide are basic oxide, therefore they can react with acid to form salt and water. Since they are basic oxide, therefore they have no reaction with base. Sodium oxide is a basic oxide because it can react with acid, and when it is soluble in water, hydroxide ions are being produced. For example, sodium oxide react with hydrochloric acid and acid to produce salt and water. Because sodium oxide can react with an acid, so this indicates that the sodium oxide is the basic oxide. Besides this, sodium oxide is also soluble in water. When it reacts with water, sodium hydroxide, which consists of hydroxide ions, are being produced. So again, this indicates that sodium oxide is the basic oxide because when soluble in water, hydroxide ions are being produced. Magnesium oxide is also a basic oxide, and it is partially soluble in water and can react readily with an acid. For example, magnesium oxide can react with hydrochloric acid to give us magnesium chloride salt and water. Since magnesium oxide can react with acid, hydrochloric acid, this indicates that magnesium oxide is a basic oxide. Now we move on to look at aluminium oxide. Aluminium oxide is an amphoteric oxide and it is insoluble in water. Amphoteric means that aluminium oxide has dual nature. So means that aluminium oxide can react with both acid and also the base. Again, aluminium oxide is an amphoteric oxide. It has dual nature, which allows it to react with both acid and also base. For example, aluminium oxide can react with hydrochloric acid to give us aluminium chloride salt and water. As it can react with an acid, so this indicates that aluminium oxide is a base. It can also react with base, for example NaOH, to form sodium aluminate salt and water. As it can react with base, this indicates that the aluminium oxide is an acid. So these two examples implies that aluminium oxide is an amphoteric oxide having dual nature, can behave like a base reacting with acid, and also can behave like an acid react with base. How do we get the chemical formula for aluminium chloride salt? Again, aluminium group 13 element with oxidation number +3, chloride oxidation number -1. Ignore the charge, cross, we get 1, 3. Therefore, the chemical formula for aluminium chloride salt is AlCl3. And for sodium aluminate salt, sodium group 1, +1 oxidation number, aluminium group 13, +3 oxidation number, oxide oxidation number -2. So total for the cation, the charge is +4. We ignore the charge, so 4. And for oxide, ignore the charge, so 2. We cross, we get 2, 4. Simplify, 1, 2. Therefore, the chemical formula for sodium aluminate salt is NaAlO2. Now we move on to look at silicon dioxide, Tetraphosphorus dicoxide, sulfur trioxide, Dichlorine heptoxide. These 4 oxides are acidic oxide. For silicon dioxide, it is insoluble in water, while the other 3 oxides are soluble in water. Since they are all acidic oxide, therefore they have no reaction with acid but can react with base to form salt and water. Silicon dioxide is an acidic oxide because it can react with strong concentrated base to form salt and water. For example, silicon dioxide reacts with sodium hydroxide base to form sodium silicate salt and water. Since it can react with the base, this indicates that the silicon dioxide is the acidic oxide. How do we get the chemical formula for sodium silicate salt? For sodium ion, it is group 1 element, so having the oxidation state of positive 1. So sodium ion having the charge positive 1. While for the silicate ion, the total charge is 2 negative because silicon in the silicate ion having the oxidation state of positive 4 since it is group 14 element, and the oxygen in the silicate ion having the oxidation state of negative 2. So positive 4 silicon plus 3 negative 2 give us total negative 2 as the charge of the silicate ion. So sodium ion charge positive 1, so 1, and the silicate ion 2, and then cross we get 2, 1. Therefore, the chemical formula for the sodium silicate salt is Na2SiO3. Tetraphosphorus pentoxide P4 or Tang is an acidic oxide because it can react with a base and also soluble in water to produce hydrogen ion. For example, P4 or Tang react with sodium hydroxide base to form sodium phosphate salt and water. As it can react with a base, this indicates that P4 or Tang is an acidic oxide. How do we get the chemical formula for the salt, sodium phosphate? Again, sodium ion having the charge positive 1, while for the phosphate ion having the charge 3 minus. Why phosphate ion having the charge 3 minus? It is because phosphorus is group 15 element with oxidation number of positive 5, while oxygen in the phosphate ion having the oxidation number of negative 2. Positive 5 plus 4 multiplied by negative 2 give us negative 3 as the total charge of the phosphate ion. Then sodium ion with the charge positive 1, 1, phosphate ion with the charge 3 minus, 3, cross we get 3, 1. Therefore, the chemical formula for sodium phosphate salt is Na3PO4. Tetraphosphorus pentoxide, the acidic oxide, is also soluble in water. When it dissolves in water, an acidic solution of phosphoric acid is being produced. Sulfur trioxide is an acidic oxide because it can react with a base and when dissolved in water can produce a solution with hydrogen ion. For example, sulfur trioxide SO3 react with sodium hydroxide base to give us sodium sulfate salt and water. As it can react with the sodium hydroxide base, it implies that sulfur trioxide SO3 is an acidic oxide. Sulfur trioxide is also soluble in water to produce an acidic solution which consists of hydrogen ions. The acidic solutions that produce is sulfuric acid solution. Dichlorine heptoxide Cl2O7 is also an acidic oxide because it can react with a base and also soluble in water to produce solutions with hydrogen ions. For example, Dichlorine heptoxide Cl2O7 react with sodium hydroxide base to produce sodium perchlorate salt and water, as it can react with a base. Therefore, dichlorine heptoxide Cl2O7 is an acidic oxide. How do we get the chemical formula for the sodium perchlorate salt? Again, sodium group 1 element with oxidation state of +1. So the charge of sodium ion is +1. And for the perchlorate ion, the charge is -1. How do we get the charge -1? Again, the oxidation state for chlorine in the perchlorate ion is +7 because chlorine is group 17 element and the highest oxidation state it can achieve is +7. And for oxygen in the perchlorate ion, the oxidation state is -2. So +7 plus 4 -2 giving us -1 as the total charge of the perchlorate ion. Then sodium ion charge +1, 1, perchlorate ion -1, 1, cross we get 1, 1 to give the chemical formula for sodium perchlorate as NaClO4. Dichlorine heptoxide is also soluble in water. When dissolved in water, an acidic solution which consists of hydrogen ion is also being produced. And the acidic solution that produced is perchloric acid solution to indicate that dichlorine heptoxide is an acidic oxide.